Hi everybody and welcome once again to Capricorn Radio with your host James Swagger. I got a quick newscast today. I've been rolling out some newscasts of late with some articles and science issues, and I've got a returning guest today because he's published an article that's been first published. I think there was two articles, one 28-year-old and one 20, and I've offered my good friend Rand Flemeth to come back to talk about it today. So I'd like to welcome Rand back to the show. Hi Rand, welcome to Capricorn Radio once again.
Oh, it's great to be back, James.
Yeah, and I could talk about Earth crust displacement all day because I love the anthropomorphic viewpoint of all this, that, this is important. This is part of us. This is not just some episode in history. This affected us, Rand, If this is what we say is true, and something happened in the Ice Age, and I think this is the only theory that really tackles it, Rand. And you wrote two articles that, which obviously one hadn't been published before, and one was a 28-year-old one and one's 20, and you've just recently put them on your homepage and phlegmath.com. That's phlegm-ath.com, and I'll put the link in the YouTube description. But wonderful articles, Rand. Why did you not publish these before?
The first one, I tried a couple of places to publish them,
right.
But there was completely closed mind about the idea of rapid polar wandering or Earth crust displacement. During that time, there wasn't. I had been very fortunate to have been published in the Anthropological Journal about agriculture
right.
in 1981,
mm-hmm.
But the climate was pretty bad, and it still is. Nobody's really seriously looking at these fundamental questions.
Let me just say, Rand,
about our past.
Let me just say at the start of your article, you say, this is on the 28-year-old one, you say, this is a think piece on the Ice Ages written in 1985. The current poverty of thought on the issue of the Ice Ages is highlighted by the fact that this 80-year-old paper is still relevant today. And that is true, Rand, and that's why I wanted to bring you on the show, because there's nothing in the article that's outdated, and there's nobody tackling this. And I think you're the only one that really addresses this in a scholarly manner, Rand. And I will say that, and I love what you do. I really do. But there was a couple of things in there that I hadn't been aware of. And in the second article, the 20-year-old one. But let's get into some of it, Rand.
Sure.
These articles are like mini books, by the way, I should say for the listeners. They're like little mini books, so that's what I like about them. They're detailed, they got all the references there, and it's just like a published paper, But this forest that was discovered, this is the key thing, Rand. There was a forest discovered in Antarctica, and it's just thrown everything up in the air. Perhaps maybe just tell us about that.
The fact is that it's a deciduous southern beech forest, and it's right underneath the South Pole.
Mm.
It's only like 250 miles from the South Pole.
Wow.
And, this is under 1,830 meters above sea level.
At the South Pole.
And the ice there is probably a kilometer thick.
Wow.
So you have under there, when you go down there, this is, again, like I say, this is only 250 miles from the pole, South Pole. You go down there, you find evidence of a deciduous southern beech forest. And they date it between 2 and 3 million years ago. So, it's not, directly related to Earth crust displacement in that sense, but it is in this sense that the current paradigm of plate tectonics, which I don't dispute. People keep saying I'm disputing it and that it superseded the Earth crust displacement and all this stuff. They are different whole Earth theories which are sister theories in my view.
Yes.
Plate tectonics it works from a gradualist assumption. And as I explained in this article, Earth crust displacement works from a punctuationalist assumption. That is, there are long periods of slow, gradual changes, and then there's periods of punctuated change when major events occur.
Mm-hmm.
And that's what punctuationalism is. And it was put forward by Stephen Jay Gould in their mid-60s. He was quite an excellent writer, Harvard professor. He well-known writer. He died of cancer not too too long ago. I actually met him personally once
Right.
in Victoria and got him to sign one of his books, which is a treasure of mine.
Wonderful.
Yeah, he wrote a lot. He wrote for a lot of articles for Natural History magazine, and those turned into books. And his books are just, well, he's one of these scientists who has the ability to write and engage, and he brings things into common, compares things to everyday life. So he's one of these sort of Attenboroughs of writing, if you like.
Yeah.
And so he was a great thing, and he and another Niles Eldridge put forward the idea that uniformitarianism, which is the prevailing paradigm of geology, is misguided in the sense that it is an ambiguous idea. It contains two ideas rather than one, but it parades itself as one idea, the one scientific perspective. But there are two ideas in there, and he in this article I explain how he explained in 1965 that there's the idea of physical laws being invariant, that they're always uniform throughout the universe, and that is an assumption that of all science.
Yeah.
And so he has no dispute with that. The other element of it is gradualism. Gradualism can explain everything, and he goes and he says, no, I'm sorry, gradualism can explain a lot, but it can't explain everything.
Yeah.
And that's where this beech tree forest underneath the South Pole comes into play, because to get that part of Antarctica into a temperate zone, which would be required to grow these plants, you have to have change that is much more rapid than just 3 million years. The plate tectonics in 3 million years cannot move Antarctica into a temperate zone. In 3 million years, it just can't do it.
Throws a major problem out there, doesn't it? There's a major problem now. It may be 2 million years versus 50 million years, but it plate tectonics doesn't work anymore. Not to explain the forest anyway. It still works, but it still works. But
plate tectonics works for all the problems that it's trying to explain. Earthquakes, uplifts, downlifts, all the things that volcanoes, the things that it's trying to explain, the subduction zones, all the stuff that it's doing fine, and I'm not disputing that. What Hapgood and I have disputed with plate tectonics is that it is the whole. It explains everything about the Earth, and we're saying no. There are events such as the end of the Ice Age, origins of agriculture, mass extinctions, that happen in what cannot be assumed gradualist way.
Yeah.
It is a rapid way. And so that's why the paradigm of uniformitarianism, we believe, is obsolete. Incorporates it by saying, yes, normally gradualism, but occasionally punctuated change. So that's what punctuationalism has superseded uniformitarianism. This is where the real shift is happening. It's at the philosophy of science level, not at the science per se, because punctuationalism applies in anthropology and archaeology as well as geology. So this is a big scale change that Gould and Eldridge put forward in the mid-'60s, which normally takes 50, 60 years to be incorporated, and we're getting to that point now.
Yeah, and here's the thing. So, this is why rapid polar wanderings come about. Now, rapid polar wanderings probably saying more than that. It's saying within thousands of years, not an abrupt change even perhaps like this, that this could happen. Like, it's not just, yes, the beech theory, the beech forest throws out the everything in the midst, and it's got problems with it. But this rapid polar wandering is the theory, and let's tie in the Martian lithosphere, because there's evidence that somebody's took this and put this to the Martian system, and perhaps there's polar wandering there too.
What happened was Peter Schultz, who was investigating Mars, noticed that that when an asteroid or a comet or anything hits the Martian surface, and it has a crater impact that has different types of signatures. The signatures that occur in the polar area are unique. They're different from ones when you're hit in the middle of the planet. But when a crater is formed at the pole, it has a specific type of signature. And so what Schultz did was he looked around the globe of Mars and said, are there places where these polar attributed craters are located outside the current polar zone in Mars? And he found them, and he also found them near the equator, and he found that they were antipodal. That is, there was ones on either side of the planet, exact opposite sides of the planet.
Wow!
And so that told him that at one time these crater that part of the Martian surface was at the pole. Both sides were at the pole, which are currently at the equator. And the only way he could explain that would be that if the outer crust of Mars occasionally displaces,
mm-hmm.
and it would have to be relatively rapid to do that because it's not like plate tectonics is working on Mars. Mars has got more of a shell outside. So,
what about the size of Mars as well? Would the size of Earth not have more liquid inside it, more viscosity or less viscosity, I should say?
Well, sure. Since the Earth is larger, that's true. But the main thing that's different about the Earth compared to Mars is that crater impacts get absorbed by vegetation and disappear in a sense from the site.
Mm-hmm.
You know, they're going down and they're actually physically disappearing from the surface of the Earth. So the Earth is a much more active and volatile.
It's erasing all the evidence.
Planet.
It's erasing all the evidence in a way, Rand.
Yeah, you're aging it all away. Whereas on Mars, because it's so barren and everything, that evidence is starkly there.
Mm.
So the main thing about the whole thing about being that Mars's crust occasionally displaces, according to this article, which was written in 1985. The thing is that we can apply that same methodology to the Earth, and when we do, we find that we're finding that the great ice sheets on Earth are antipodal, that is central Greenland and eastern Antarctica,
mm-hmm.
and yet they're lopsided relative to the Earth's axis.
Yeah.
So they're not right over the poles, they're to the side.
Yeah.
And so that would be, if you were looking at the Earth objectively, if you had just arrived at Earth from some other solar system and you saw, here's a planet that has its ice lopsided and antipodal, that means that the crust shifts here.
Mm-hmm.
That would be the logical conclusion. That anybody who wasn't fixated within the paradigms of the planet would have when they looked upon this planet.
But this is the thing, Rand. Earth crust displacement directly, absorbs this as a theory. It takes all the information in. It's looking at it in a scientific manner. It's really addressing it, isn't it? This Earth crust displacement is addressing all these issues.
It is, and it isn't just a question of the antipodal ice as well. It's about the rapidity of the changes that occur. The assumptions of gradualism and uniformitarianism are shattered by the fact that an ice sheet was on North America the size of the one on Antarctica like 12,000 years ago, and now is gone, and all we have is Great Lakes.
Mm-hmm.
That's a rapid 12,000 years, we go from ice sheets 2 or 3 miles thick on over New York and Chicago and Detroit, and now you have lakes. 12,000 years later. I mean, plate tectonics cannot account for that. Mm-hmm. And we have to have some whole Earth theory that it can explain these rapid changes, and we believe that Earth crust displacement, which is just simply a better articulation of rapid polar wandering, because rapid wandering kind of doesn't make sense.
Yeah.
You don't wander rapidly. You wander leisurely normally.
Yeah.
And the whole thing is couched in uniformitarian jargon. So when they accept the idea that the Earth's crust as a whole might shift relative to the Earth as a whole, as opposed to the plates individually in relation to each other, they use the word wandering because they want it to be slow. And so Hapgood rejected that and said, no, it's a displacement. It's not a wandering.
Yeah, it's sleight of
he
hand.
called it Earth crust displacement.
Yeah. Yeah, it sounds like sleight of hand when you say it like that. But let's talk about up in Siberia as well, because at the other end, at the other antipodal evidence, we have what you mentioned in the article about Baron Toll, the explorer, who found, I didn't know this now, a 90-foot fruit tree, and the saber-tooth.
Yes.
And see, I always heard earth crust displacement, Antarctica shoved into the South Pole, and the woolly mammoths frozen overnight, and the fresh buttercups in the belly, and it's kind of all that I ever hear bandied about, and it's always ever gets regurgitated, and that's great, like. But I mean, I never hear about the saber-tooth as well, and you never hear about the 90-foot fruit tree in Siberia.
Yeah, and these, in both these articles that I've put up here, the New Siberian Islands are important. The New Siberian Islands are north of Siberia. They're in what today is the Arctic Circle and the Arctic Ocean, what we call the Arctic Ocean. And they're well within the Arctic Circle, and very, very cold place. No, none of these kind of animals. You certainly couldn't grow fruit trees there now.
Yeah.
But yet, when the first explorers got there, then when this Baron Toll got there, he found the remains of a saber-toothed tiger, and he found a 90-foot fruit tree that was still standing. And so, like that does not make sense in terms of uniformitarianism. If the latitude of the New Siberian Islands has always been where it is today, then it doesn't make sense that during an ice age, when New England and New York, Chicago, Detroit are all under a mile of ice, that up here in Siberia, which is closer to the pole in our calculations, is growing 90-foot fruit trees. That doesn't make any sense at all. And so basically what's happened is that most of that evidence was ignored. And then it also got ignored because of the Cold War. And anything coming out of Russia was suspect. Now, the Russians had no problem whatsoever about believing that Siberia had been temperate during the last ice age. And they continued to publish things about that. I mentioned the article in Yana in Atlantis Beneath the Ice. And it's on our website under Bits That Don't Fit. Here's a place that's 33,000 years ago had all these humans living there during a time when North America was, as is Antarctica is today, an ice-encapsulated continent. Virtually only the outer edges of it, California and Florida and that area were not under ice, but most of North America was under ice. And yet here in northern Siberia, which is, if we assume that the latitudes of the Earth are constant, which everybody is still assuming and is what we're questioning, you have these animals, plants and animals living up there that can only exist in temperate conditions.
Yeah, here's the other thing as well. This is all directly linked with the Ice Age rants. And the Ice Age was a very, very special time on our planet. Very important time that really we don't know anything about. We're really, really struggling to get a grip on it. But, I mean, this Earth crust displacement is linked with the Ice Age. It's linked with the Pleistocene extinction, the peopling of America, the agriculture. This just screams sense to me, Rand. It just makes sense over and over from so many different points, like all stuff that you addressed in this article. And you know what, Rand? I just love this article that I was just a joy to read it, and I was like, this is well laid out, structured information, and that's what I love. Perhaps tell us about the peopling of America and where that fits in, and there's something in there that I hadn't been aware of as well. I was aware of the Clovis culture, and that kind of throws in this Siberian to Alaska connection. Sorry, not Siberia, the Alaskan to Siberia, the crossover. The land route, as they call it, like,
the Beringia,
the Beringia, that's right. I don't really buy that. I never really did buy that. I couldn't understand why man had to walk all the way around the globe to get to this. It's almost like a childish explanation to how we got to America. It's.
Yeah, well, I have felt for a long time, and really, there's a fellow named Fladmark. He's mentioned in the bibliography of this, the citations on this one, Does the Earth Shift? He put forward the idea that, it's really the coastal regions that were more likely that they came along the coast of British Columbia. This ice-free corridor idea really was, didn't really have a lot of credibility in my view. When you look at our map 5 in this article shows the North America as it was according to the Earth crust displacement model of the past, and it shows that that what we call now the West Coast was the South Coast, that British Columbia was on the South Coast, directly north was towards Hudson Bay. Alaska was to the west, and California was to the east of British Columbia rather than to the south and north. And so you have a completely different orientation. And when you take that orientation and you look at the situation as it was 12,000 years ago, then you see that the ice-free corridor is a very daunting thing. You're having to move towards the pole and then go down these ice sheets to get there. Whereas if you're living on the south coast of Siberia and Beringia, you just follow the same thing that you're doing, which is fishing and hunting, salmon, seals, whatever, and you just there's no adaptation in terms of your culture to get all the way down to Washington State. You're simply it's an extension, and not only that. It's a journey that takes place from west to east rather than from north to south as we think it has taken place. Which it all goes to the point that the Earth's latitudes are assumed in science to be fixed.
Yeah.
That they are constant. That is the assumption, the presupposition, if you like, that we're questioning. We just do not accept that. We say that no, the latitudes of the places of the Earth relative to the latitudes or climatic zones is a variable. That the crust moves through these climatic zones. You can go from a temperate zone to a polar zone, or a polar zone to a temperate zone. You can be in between, and in a tropical zone, both before and after. You can go from a tropical to a temperate to a tropical, and all those categories. There's 7 different categories of changes that occur are listed in the maps that are shown in this, and each one of those categories, each one of those areas, coincides with physical evidence that supports it.
Yes. Yes.
When you look at map 1, for example, and you see what's called the interpolar zone, it's within the Arctic Circle today, and it was simultaneously before the last displacement. It was also in the Arctic Circle, and that's where Greenland is, and that's where all the ice is. So we're not too surprised. When you look at what I call the paleopolar or old polar zone, that is basically North America. It goes from being in the Arctic Circle to not into the temperate zone, and that's when all the ice melts. So that's consistent.
And
when you look at
Yeah, and
all of them are consistent.
Yeah, and this is the way the evidence interlocks. I mean, Rand. I mean, 96,000 BC. Sorry, yeah, 9600 BC. Hunter gatherer. That was it. Like, we were hunter gatherer before that. It's pretty accepted anyway. And I mean, we have the emergence of agriculture in around the same time, and we have, you know, this interlocking evidence. Like, you know, our agricultural origins are tied in with this epoch, and an earth crust displacement talks about the migration of the plants and the crops and the temperate zones, and you know, it just all interlocks and makes sense. It's like the piece of the puzzle that explains it all. I guess, you know, for me anyway.
Well, you know, some of the biggest ideas are very simple, and this idea is really simple. It's just that it's so different from what our assumptions are.
Yes,
we assume that the Earth's crust is stable, and we try to explain the ice ages by imagining that the polar zones are expanding. But that's not what happens. We're always in an ice age. It's just that that part of the land where the crust shifts that ends up in the polar zone is in an ice age. So today there's an ice age on the New Siberian Islands. 12,000 years ago there were fruit trees there. I mean, now it's in an ice age, and so there's an ice age at all times. The ice ages have been misconceived. It's basically the climatic zones are stable because the Earth's axis doesn't change in an Earth crust displacement. So you're getting the same climatic zones, polar, temperate, tropical. But you're moving, the crust, the whole outer shell of the Earth is moving, so that parts of it are going in and out. And some parts are getting warmer. See, this is the thing that that's problematic for the ice age theories, is that, you know, there are areas, if they have to assume that the polar zones are expanding, the cold climate is fanning out from the poles and encapsulating the hemisphere. But that doesn't work because there's areas that are warmer, like Siberia was warmer. You know, so you get Earth crust displacement can explain places being colder, warmer, staying the same. And the other theories cannot do that. They have to have, all temperature has to be moving in one direction, everything. And that's not what the physical evidence shows. So it's just a challenge to a presupposition, and the presupposition is that the Earth's crust is stable, and that the climatic zones are variable. And we're just saying, no, that the climatic zones are a constant, and the Earth's crust is a variable. And that's the only thing. That's a simple idea. It's a very simple idea. It's just that it's so different from what everybody else is used to that they can't accept it.
Yeah, you know, this is the thing, Rand. I mean, who's doing ice ages? Is there people working trying to crack this problem? Is there anybody sitting addressing this? I mean, I know there's like loads of Antarctica bases there. I mean, I often go into Google Earth. If you've ever been on Google Earth, Rand, you can. I'm doing a little video for the people because I do a little Google Earth video sometimes for newscasts. You can look at places and anomalies all around the globe, but there's a whole list of Antarctica bases you can zoom in on Google Earth, and you want to see the operation there, Rand. It's crazy, but I mean, you wonder, are they addressing any of this with all their science bases down there, or? You know, is that what they're...
Well, you know, the attempts to explain the ice ages have normally revolved around changes in the Earth's tilt and orbit.
Right.
And I think that if anybody reads Fred Hoyle's book, Ice, he completely demolishes that
right.
in his book. And, you know, he it just doesn't work. And we... in this article, Temperature, Tempo, and Symmetry in Ice Ages, which is a think piece I did in '85.
Yeah,
I tried to show the symmetry part of it, apart in addition to the antipodal ice sheets on central Greenland and greater Antarctica. We took it to the mountains glaciation in Hawaii, and then we went right across to the same latitude in Thailand and found another mountain, same altitude and everything, that wasn't glaciated. So here you have an anomaly to the fanning out of from the pole idea of ice ages. Why would there be glaciation on Hawaii and not glaciation in Thailand? Even though they're at the same altitude and the same elevation, these two mountains that we mentioned, one is glaciated, Hawaiian, and one in Thailand isn't. And the way we explain that is, of course, well, when the Earth's crust during the past 3 Earth's crust displacements, Hawaii at one time was much further north than it is now. So it could have received glaciation. Whereas the one in Thailand has never been out of the tropics, and that's why it doesn't have it. So we show in the cases of mountains there. Then we also take, in the southern hemisphere, we take 2 islands, one Heard Island, which is in the Indian Ocean southwest of Australia, and it's an island, and it's the same distance from the South Pole as South Georgia, which is in the South Atlantic. Now the question is, why wasn't it glaciated during the last ice age? And the evidence shows, and they've done thorough studies of South Georgia, it wasn't glaciation. Yet on Heard Island, there is glaciation, and there is even massive ice sheets, even there today, because this is antipodal to Saskatchewan in Canada, and where all the ice sheets were.
Sure.
So what we show is that Heard Island before the last Earth's crust displacement was around 82 or 83 degrees north, which is 7 degrees from the pole. Of course it's going to be ice age. Whereas South Georgia was around 38 degrees south, which is well out of the range where there could be ice. So the latitudes on these islands, which are the same, they're the same distance today from the pole, yet they have dramatically different glacial histories. And that is explicable with Earth's crust displacement, but is not explicable with any other theory.
Wow.
There's no other theory that can explain why South Georgia was unglaciated, yet Heard Island was glaciated, and likewise with the mountains of Hawaii and Thailand. So those are the symmetrical tests that we're talking about when we're looking at ice age theories. So temperature, it's not all uniform going one way. There's places that are getting warmer. There are places that are remaining the same. Tempo, this pace is way faster than gradualism can assume. And symmetry, those are the tests that I mentioned. That's what that article is about.
Sure, and the thing is, we're only addressing the last Earth's crust displacement, but looks like there's been many Earth's crust displacements, Rand.
Yes, hundreds probably. Well, if there's been 3 in the last 100,000 years, you can imagine how many there have been over billions of years, a couple of billion, 4 billion years. It's a lot.
Do you think then? I know you addressed this from a scientific and scholarly manner, but I'm going to get you to speculate. Do you think of a periodicity of when this might occur, or does that occur to you, or do you like to address that?
Yeah. I did think about that, and this is where I varied from Hapgood as well. I think the best evidence is the last Earth's crust displacement at 9,600 BC. Mm-hmm. That's the best evidence. So then you have to ask yourself, what were the conditions there, in terms of the Earth's position? Mm. The thing that's the most striking is that the Earth's tilt at that time was at its maximum, 24.4 degrees angle, rather than 23.5 today, and down to 21.8. Mm-hmm. And we're still declining. So, it was at its maximum tilt, and that probably makes the Earth's crust more vulnerable to a displacement when the tilt is at its maximum. And so that is a 41,000-year cycle. And that seems to be registered in the geological record as well.
Yeah. So
my feeling is that these displacements happen when we're at maximum tilt, which is at 24.4, and that's not for another 29,000 years. So we're not due for another Earth crust displacement if that theory is correct for another 29,000 years, which is good. Which means the Earth is young. Yeah. Relative to what it's
we're safe for a while, aren't we? So
we've only used up 12,000 of the. We've not even used up 12,000 of the 41,000 years that we have.
Sure, they talk about earthquakes happening at the moon's gravity might depends where the moon's at, and the sun and the way gravitational bodies line up, and if they're all synced at the right time, these all effects might accumulate. It doesn't mean there's going to be an earthquake, but the chances of an earthquake might be happening. And I sometimes wonder, is there like a solar system event, Rand, perhaps where bodies line up in a line, or maybe our place in the wider scheme of things, like, is there a precessional cycle of us moving around other stars, or maybe the precessional cycle's linked in with it? And that's maybe what I think, Rand. But it doesn't mean, just like the earthquakes happening, doesn't mean the earthquake's going to be guaranteed. I mean, the conditions might favour an earthquake, whereas the conditions might favour an earth crust displacement. Doesn't mean it's always going to happen, which was why might miss it one year and have it the next, and that's why the periodicity might change. But the periodicity of it, the events being likely.
Well, yeah. I mean, I think you come in through and you pass through danger zones, and you might get hit during that danger zone, or you might not. Just like the Earth is more subject to being hit by objects from outer space, because their orbit takes us through areas which are more prone to be hit. So, like, if we're going to be hit by an asteroid or something like that, it's most likely to happen in October, November. That's when we're going through that area of the Earth, of space,
sure,
where it's more danger. It doesn't mean that it's going to happen. It just means that it's more likely
exactly
to happen. It doesn't mean it wouldn't happen in July or sometimes as well. It just means that the chances of things happening at certain times are greater.
Yeah.
And I believe that's what happened 12,000 years ago. We were at maximum tilt, made us more vulnerable.
Mm-hmm. Wow, what a fascinating subject, Rand. Give us out the place we can get these articles, Rand. Give us your website. And
well, it's just at our flemeth.com. It's FLEM hyphen or dash if you're American, ATH.com. So FLEM-ATH.com.
Yeah, and I have a link up on I have a link up on your biography page as well on Capricorn Radio if people want to follow there.
Oh, that's cool.
Yeah.
And I should say that this paper, Does the Earth's Crust Shift, was the paper that probably persuaded Graham Hancock to adopt the theory of Earth crust.
Yeah, I know Graham. I remember watching Graham Hancock on the DVD box set, and I can't remember what it was. He was at Stonehenge, just going back to the 90s now, and I remember him talking about your work and that, and he really has absorbed you in and loves what you do. He really does, and it gels with Graham as well, I think. But Graham's a lot of admiration and respect for your work, Rand, as do I, and many others. We love what you do, really do, because you're quite thorough in what you do, Rand. You're very, very thorough and very, very scholarly, and that stands to you. It stands to any researcher, Rand.
Basically, I've written very popular books, like When the Sky Fell, The Atlantis Blueprint, and Atlantis Beneath the Ice. And those are written for a popular audience. And these think pieces that I've recently put up are the thinking it's in the background, if you like, to what I've been doing.
Yes.
And this is a more rigorous, if you like, look at the problems than you would get in the books.
Yeah.
The books are meant to be entertaining and giving you the information, but in an entertaining way. I'm not really trying to entertain people with these articles. I'm trying to explain why the current assumptions are false, and that by adopting a simple, different assumption, all these bottlenecks in science, and it's not just geology; it's archaeology, anthropology, paleontology. They're all in bottlenecks. These bottlenecks just burst open, and we pass right through and move on.
Sure.
Just by making this one assumption change, that the Earth's crust is variable.
And that's why I wanted to do a little newscast on these two articles that you put on the website, Rand. It's like, they're great articles. They really are great articles. I guess the big question before we wrap it up then is, these aren't outdated in any way. They stand today as they did then, I think, but what is different today? Is there anything different today? Perhaps we've already done that in our previous show. Maybe new evidence, slightly little extra pieces of evidence added into the mix. Maybe is that all different today?
Yeah, I mean, certainly we put a lot more evidence in Atlantis Beneath the Ice in terms of updating the things that have occurred. But fundamentally, these papers still stand because fundamentally there hasn't been a change in the presupposition of uniformitarianism. There hasn't been even though it's been called for by probably one of the greatest geologists of our time, Stephen Jay Gould. He was certainly one of the greatest geologists of our time, and he called for a change in it, and it still hasn't happened. And he called for it in 1965, well before I wrote 20 years before I wrote these papers. So here we are on 50 years later, and it still hasn't been absorbed that uniformitarianism is obsolete. I'm not saying plate tectonics is obsolete. I'm saying gradualism as a pervasive, all-encompassing, fully unimpaired notion has been disqualified, and logic from the philosophy of science point of view, and also from the physical evidence of the Earth.
Wow, what a fascinating discussion, man. I love Earth crust displacement because I see it, and I see the solution that it solves, and I see what it addresses, and I love it. I loved Hapgood's work, and I wasn't aware of Hapgood's work till I had found Graham Hancock's work, which then led me to you, which then led me to Hapgood's, and I look at it all now. And again, with the maps as well, we never touched on that. That also gels in with the cartography. That maybe this is, Graham would talk about that, I think, a lot as well, and that these maps maybe kind of add into the mix as well. I know you addressed the ice and the geology and stuff, but I mean,
certainly in the popular books, the maps have always been a part of art, right from when the Skyfell came out.
But I mean, what I like about these articles is, Rand, they're very scholarly, they're very academic, and it's different. Like you say, that's what I liked about it. That's why I wanted to do the newscast and say, look, go and have a look at these articles, because a lot more people are reading this stuff now, Rand. You want the articles as well as the popular stuff. I mean, the popular covers the masses, but then there's people within the mass media now that are reading the popular books. They want to see some of the articles too. So I recommend everybody to go to your website, phlegm-ath.com, and check out the articles, because they're a great read and they're very scholarly, and all the links and the references are there. It's just like a little mini book, Rand. So it's been a pleasure having you on the show for the newscast. It really has, Rand. Come back anytime, my friend.
Thank you very much, James.
Yeah, sure. Come back anytime, Rand.
Okay, great.
Take care.
Thank you.